Good morning, students. Last two lectures we have discussed the essentials and prerequisites of exercise 4A. Okay, so where we have derived the equation of the ellipse and various forms of the ellipse, eccentric angle, next few definitions of chord, focal chord, lattice rectum, etc. So let us start the exercise 4A. The first question is, find the equation of the ellipse with focus at 1, minus 1, E eccentricity 2 by 3 and the directrix as x plus y plus 2 equals to 0. So this is the definition of a conic itself. So given that focus is represented by the letter S is equals to 1, minus 1, lattice rectum, directrix L, x plus y plus 2 equals to 0 and eccentricity E is equals to 2 by 3. So 2 by 3, if you divide, so we will be getting 0.6 approximately. So that means which is between 0 and 1, E less than 1. So according to the definition of a conic, before that let P x1 y1 be any point on the locus of P, locus of ellipse. So according to the definition of a conic, its distance from a fixed point SP by its distance from a fixed line PM is equals to E. Implies SP is equals to EPM, where SP is the distance between the 2 points S, P, and PM is nothing but perpendicular distance from P x1 y1 to the line x plus y plus 2 equals to 0. This implies SP square is equals to E square PM square. SP is the distance between x1 y1 and 1, minus 1. SP is square root of x1 minus 1 whole square plus y1 minus of minus y plus 1 whole square. SP square is square and root will be cancelled. We will be getting x1 minus 1 whole square plus y1 minus of minus. So y1 plus 1 whole square equals to E square into, what is E square? 2 by 3 whole square, 4 by 9 into PM square. So PM is the length of the perpendicular distance from the point P x1 y1 to this line. So x1 plus y1 plus 2 by square root of square of the quotient of x 1 square plus square of the quotient of 1 y 1 square. This is the modulus whole square. This is equals to 1 plus 1 root 2 whole square is 2. 2 nines are 18. Cross multiplication 18 into x1 minus 1 whole square plus y1 plus 1.
This is the required general solution of the given differential equation.
x1 plus y1 plus 2 whole square. This is equals to 18 into x1 square plus 1 minus 2x1 a minus b whole square plus y1 square plus 1 plus 2y1 is equals to 4 into, this is a plus b plus c whole square, a square plus b square plus 2 square 4 plus 2x1 y1 plus 2 2s are 4y1 plus 2 into x1, so 4x1. This is equals to 18x1 square minus 4x1 square, so 14x1 square. Now, this is 4 2s are 8x1 y1. If you transpose minus 8x1 y1. So 18 into y1 square, 18 y1 square. This plus 4 y1 square, if you bring here, minus 4 y1 square. 18 minus 4, which is 14 y1 square. Next. 18 2s are minus 36. This is 4 4s are 16. Minus 36 minus 16 minus 52x1. 18 into 2, 18 2s are 36 y1. This is 4 4s are 16. Plus 16 if you bring here, 36 minus 16, 20 y1. Next. 1 plus 1, 2. 2 18 is 36. This is 4 4s are 16. So that is 20 equals to 0. So therefore the locus of P x1 y1 is, and we can take 2 as a common throughout the entire equation. Therefore the locus of P x1 y1 is 7x square minus 4xy plus 7y square minus 26x plus 10y plus 10 is equals to 0. So this is the second degree non-homogeneous equation. Under the second degree non-homogeneous equation, to represent ellipse is h square is less than ab. What is h here? H here is 2h is minus 4. H is equals to minus 2. H square is 4. And AB is equals to how much? AB is 7 into 7, 49. So obviously 4 is less than 49. Therefore, this second degree non-homogeneous equation represents the equation of the circle. Second question, find the equation of the ellipse in the standard form whose distance between foci is 2 and the length of the lateral rectum is 15 by 2. Here, equation of the ellipse in its standard form. The ellipse is said to be in its standard form if and only if the center is at the origin. We have altogether 4 ellipses discussed in various forms of the ellipse. X square by a square plus y square by b square equals to 1. When a is greater than b, a is less than b, and whose center is at the origin. And 2 more cases, x minus h whole square by a square plus y minus k whole square by b square equals to 1. Again, a greater than b, a less than b, but center is shifted to c h comma k other than the origin 0 0 without actually changing the direction of the coordinate axis. So, but the natural question arises, which ellipse is to be taken into account? A greater than b or a less than b? For the first 2 conditions. First 2 conditions are x square by a square plus y square by b square equals to 1. But one is a greater than b and another is a less than b. Unless and until something is mentioned, let us stick to the first case only. Okay, so A greater than B case. Solution. Let A is greater than B, I'll take. So if A is greater than B, the ellipse is somewhat like this. This is the ellipse. And for this ellipse, whose distance between the foci? So this is S dash and this is S. This is AE comma 0 and this is minus AE comma 0. From center C, this is AE and this is AE. So distance between the foci is 2AE. So given that distance between the foci, distance between foci is 2AE is equals to 2. So 2 gets cancelled, therefore AE is equals to 1. And the length of the lattice rectum is 15 by 2. For A greater than B case, length of the lattice rectum is 2B square by A is equals to 15 by 2. So this is equals to 2 to the 4B square. 4B square is equals to 15A. Cross multiplication, 2 to the 4B square is equals to 15A. So from this 4 into, we know that B square is equals to A square into 1 minus E square. A square into 1 minus E square is equals to 15A. Since we have proved this in the theorem also, the last step, x square by A square plus y square by A square into 1 minus E square equals to 1, where this B square is equals to A square into 1 minus E square we have taken. So B square is equals to A square into 1 minus E square. This is equals to 4 A square into 1, 4A square minus 4A square E square is equals to 15A. So this is equals to 4A square minus A square, AE is equals to 1, A square E square is 1 square into 4 minus 15A equals to 0. So 4 4s are minus 16. So factorization. So 4A square minus 16A plus 1A minus 4 equals to 0. Take 4A as a common in these two. So this is A minus 4 plus 1 into A minus 4 equals to 0. Therefore, A minus 4 into 4A plus 1 equals to 0. So 4A equals to minus 1. From this, 4A plus 1 equals to 0. From this, A is equals to minus 1 by 4. But since A is, this is A, this is A dash. So this is A. This A is the distance between the center to the one of the vertex. Is length is always positive, but here it is negative, so it is not equal. And A minus 4 equals to 0, therefore A equals to 4. Now, so since A is equals to 4, you substitute back into this here, substituting A equals to 4 in this 4B square equals to 15A. Then 4B square is equals to 15 into A value is 4. 4 gets cancelled, therefore B square is equals to 15 I got. So therefore, for A greater than B, what is the equation of the ellipse? Let the equation of the ellipse be x square by a square plus y square by b square equals to 1. Since A is greater than B, this is the standard equation of the ellipse. Substitute. So therefore, the equation of the required ellipse is x square by the value of a square is a is 4, a square is 16 plus y square by b square is 15 is equals to 1. Third question, find the equation of the ellipse in the standard form such that distance between foci is 8 and distance between the directrices is 32. So, since a special case is not given, what I mean is A greater than B or A less than B, let us take A greater than B only. That means this is the ellipse. So, let the equation of the ellipse be x square by a square plus y square by b square equals to 1 with a is greater than b. So let us take this is the equation of the ellipse. Since this is the standard form of the ellipse, its center is at the origin. This is the coordinate axis x dash. This is y dash. Now, these are the directrices. These directrices are corresponding to this fixed point and this fixed point. So this line is the directrix of this focus, which is L equals to 0. This is L dash equals to 0. And this is the foot of the directrices Z dash. Now, so distance between the directrices is, this is A by E comma 0 from the center, and this is A by minus A by E comma 0. Totally this is 2AE, and this is equals to what we have discussed earlier. Distance between the foci is 2AE. This is AE comma 0 and this is minus AE comma 0. This is AE and this is AE 2AE. So this is the data given. So given that distance between the foci is 2AE is equals to 8. From this 4 times. So AE is equals to 4. And distance between the directrices 2A by E is equals to 32. So from this 16 times, this is equals to A by E is equals to 16. Now let us divide A by E is equals to 4 by 16. From this, AE by 1 into this A by E is E by A. This is 4 fours, 1 by 4. Here A gets cancelled, therefore E into E square is 1 by 4, therefore E is equals to 1 by 2. So E we got. Now substituting E in this, AE is equals to 4. That implies A into E value is 1 by 2. E value is 1 by 2 equals to 4. From this, A is equals to 2 4s are 8. So we have, since A greater than B case, the condition among A, B, E, major axis, minor axis and the eccentricity is B square is equals to A square into 1 minus E square. So from this, B square is equals to A square into 1 A square minus A square into E square A square E square. The value of A square is 8 square 64 minus AE is equals to 4. A square E square is 4 whole square 16. So this is equals to 48. Therefore this is B square. Therefore equation of the required ellipse is x square by A square. A is 8, A square is 64 plus Y square by B square is 48 is equals to 1. The fourth question, find the eccentricity, small e we need to find, of the ellipse in its standard form. What is the equation of the ellipse in its standard form? X square by A square plus Y square by B square equals to 1. Whose center is at the origin. If its length of the lattice rectum is equals to half of its major axis, unless or until it is mentioned, let us take A greater than B only. So let the equation of the ellipse be x square by A square plus Y square by B square equals to 1 with A greater than B. So that is, the ellipse will be like this. So length of the lattice rectum means 2B square by A. What is the lattice rectum? So this is the ellipse, for example, and this is focus, and the chord which is passing through the focus, and perpendicular to the major axis is called the lattice rectum. So L dash, and this is also another one, M dash. So length of the lattice rectum we have proved it to be 2B square by A. The ellipse 2A square by B. So 2B square by A is equals to half of its major axis. What is major axis? Here, since A is greater than B, this is B dash. So this is seen to be greater with compared to this. Therefore A is greater than B. So here, so major axis is along x-axis. So this is 2A. This is equals to half of its major axis. So 1 by 2 into, what is A dash? 2A. Major axis. Length of the major axis is 2A, because this is A comma 0, this is minus A comma 0. This is origin. So this is A and this is another A. So totally this is 2A. So length of the lattice rectum 2B square by A is equal to half of its major axis. Now this 2 gets cancelled. So 2B square is equals to A into A square, cross multiplication. So we have B square is equals to A square into 1 minus E square. This condition we have. So you apply this condition. In the place of B square, substitute A square into 1 minus E square is equals to A square. So A square gets cancelled. So 2 into 1 minus E square equals to 1. So this is 1 minus E square equals to 1 by 2. So 1 minus 1 by 2 is equals to e square. 2 ones are 2, 2 minus 1, 1. So e square is equals to 1 by 2. Therefore, e is equals to 1 by root 2. So this is the eccentricity that he is asking. Eccentricity. The distance of a point on the ellipse x square plus 3y square equals to 6 from its center is equals to half. Find the eccentric angles. So, first of all, what is meant by auxiliary circle? From auxiliary circle, eccentric angle we have deduced the last video. So, for example, this is our ellipse and this is A dash. A dash is the major axis and the circle described on the major axis as the diameter of this circle. So the circle described on the major axis of the ellipse as the diameter of this circle. So then this circle is called the auxiliary circle. So this is C. Okay, and this is, let P be any point. What is the parametric point of the circle? A cos theta, B sin theta, which we have deduced the last video. So, and this is our x-axis, and this is perpendicular. This is Q, this is N, and this is, you join for example, then angle XCQ is the eccentric angle theta, and this theta is lying in between 0 and 2 pi. So, if P is starting from A and move in an anti-clockwise direction and again reach to this P, this A, then this complete revolution is 360 degrees. Therefore, theta is lying in between 0 and 2 pi. So this is what we have discussed. So let the given equation of the ellipse is, this is x square plus 3y square by 6. So x square by 6 plus 3y square by 6, which is y square by 2 equals to 1. Here, obviously, a square is equals to 6, a is equals to root 6, b square equals to 2, b equals to root 2. Therefore, a is greater than b. Therefore, this is the major axis is along x-axis. Now, let P is equals to, let P a cos theta comma b sin theta be the parametric point. Be the parametric point on the ellipse. So that means P is equals to how much? A square equals to 6, A is equals to root 6. So root 6 cos theta and root 2 sin theta. So what has been given is the distance of this point from its center. This CP is given that CP is equals to 2. CP is, this is root 6 cos theta and root 2 sin theta, and C is 0, 0. So distance formula, square root of root 6 cos theta minus 0 whole square plus root 2 sin theta minus 0 whole square is equals to 2. So squaring on both sides, This is root 6 cos theta squaring on both sides. So this whole square into this. Now this square and root gets cancelled. We get root 6 cos theta whole square plus root 2 sin theta whole square is equals to 2 square is 4. This is equals to 6 cos square theta plus 2 sin square theta is equals to 4. So 6 into cos square theta is 1 minus sin square theta plus 2 sin square theta is equals to 4. So this is 6 minus 6 sin square theta plus 2 sin square theta is equals to 4. This is 6 minus 4 is 2 is equals to minus 6 sin square theta plus 2 sin square theta is minus 4 sin square theta. If you transpose 4 sin square theta, so 2 times. So we get 2 sin square theta is equals to 1. So sin square theta is equals to 1 by 2. Therefore sin theta is equals to plus or minus 1 by root 2. So here theta is lying in between 0 and 2 pi. So it could be 1 by root 2 or minus 1 by root 2. So 1 by root 2 is lying in first two quadrants. So therefore theta is equals to, it could be pi by 4 or 3 pi by 4 or 5 pi by 4 or 7 pi by 4. Because sin 45 is 1 by root 2 plus 1 by root 2. Sin 135 is sin 180 minus 45. The second quadrant. In second quadrant, sin is positive. So sin 45. Sin 180 minus 45 is, sin 135 is sin 180 minus 45. Sin 45, which is still 1 by root 2. So sin 5 pi by 4, 225 degrees. So 225 degrees can be written as sin 180 plus 45. Third quadrant. In third quadrant, sin is negative. So minus sin 45. So minus 1 by root 2. Sin 315 minus 1 by root 2. Therefore, the eccentric angles could be pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. Find the equation of the ellipse in the standard form if it passes through the points minus 2 comma 2 and 3 comma minus 1. Unless and until it is mentioned, let us take a greater than b case only. So in its standard form means x square by a square plus y square by b square equals to 1. So let the equation of the ellipse be x square by a square plus y square by b square equals to 1 where a is greater than b. So the ellipse is passing through the point since the ellipse is passing through minus 2 comma 2. This implies minus 2 whole square is 4, 4 by a square plus 2 whole square, 4 by b square equals to 1. Similarly, the ellipse is also passing through three comma minus 1. This implies 3 square, 9 by a square plus minus 1 whole square, this 1 by b square equals to 1. So this is equals to, this is 1 and this is 2. Now solving these two. So second equation, I will multiply this with the 4. Then 4 nines are 36 by a square plus 4 by b square is equals to 4. And the first equation is 4 by a square plus 4 by b square is equals to 1. Solving 1 and 2. So this is equals to minus minus minus. I'll subtract. 36 minus 4 is 32 by a square. 4 by b square, 4 by b square gets cancelled. 4 minus 1 is 3. From this, a square is equals to 32 by 3. Substituting a square in the second equation, we get 9 by a square is 32 by 3 plus 1 by b square is equals to 1. This is equals to this is 9 by 1 into this is 3 by 32 plus 1 by b square equals to 1. So 1 by b square is equals to 9 3s are 27 by 32. This is 27 by 32. If you transpose on to another side, minus 27 by 32. 32 on the 32 minus 27, 5 by 32. 1 by b square is 5 by 32. Therefore, b square is equals to 32 by 5. Substituting a square, b square in the ellipse in x square by a square plus y square by b square equals to 1 will get x square by the value of a square is 32 by 3 plus y square by this is 32 by 5 is equals to 1. So this is equals to 3x square by 32 plus 5y square by 32 equals to 1. Therefore, 3x square plus 5y square is equals to 32 is the required equation of the ellipse. Seventh question, if the ends of the major axis of an ellipse are 5, 0 and minus 5, 0, find the equation of the ellipse in the standard form of its form if its focus lies on the line 3x minus 5y minus 9 equals to 0. See, 5, 0 and minus 5, 0 are the points lying on the x-axis. That means the major axis is along x-axis. That means A is greater than B case, the first case. And since he is asking the equation of the ellipse in its standard form, the center is obviously at the origin. Let the equation of the ellipse be x square by a square plus y square by b square equals to 1. So that means this ellipse and this a 5, 0 and a dash minus 5, 0 is given, and let us take this to be the center of the ellipse. So this is, if its focus lies on the line, so let us take this as S dash or the foci. So if this is the focus, this is A E comma 0 and this is minus A E comma 0, this point. So let the focus S A E comma 0 lies on the line 3x minus 5y minus 9 equals to 0. That means this is the line which is 3x minus 5y minus 9 equals to 0. So since the focus S lies on this line, this AE comma 0 must satisfy the equation of this line. Substituting AE comma 0 in the line equation, 3x minus 5y minus 9 equals to 0. This implies here A is equals to how much? So this is A comma 0, this is minus A comma 0. Therefore A is equals to 5. So that is 5e comma 0, substituting 5e comma 0 in 3x minus 5y minus 9 equals to 0. Let us substitute. So 3 into 5, 15e minus 5 into y value is 0 minus 9 equals to 0. This is equals to 15e is equals to 9. So 3 5s, 3 3s. Therefore, the value of e is equals to 3 by 5. So this is 0.6. 0.6 is between 0 and 1. So less than 1 only this is. Therefore, this is the eccentricity of this ellipse. We have E, we have A. So it is easy for us to find out the remaining B. So it is connected by the relation. We have B square is equals to A square into 1 minus E square. So this B square is equals to A square into 1 A square minus A square E square. The value of A square is 5 square 25 minus AE is this is AE whole square. A square E square is nothing but AE whole square. A is 5, E is 3 by 5 whole square. So 5 square, 5 gets cancelled. 25, 3 square is 9. 25 minus 9 which is 16. So B square is equals to 16. So from this B is equals to 4. Therefore, the equation of the required ellipse is x square by the value of A square is 5 square 25 plus B square y square by B square is 4 square 16 is equals to 1. So this is 16x square plus 25y square by 25 into 16 is the LCM. 25 16s is equals to 800. 25 16s is equals to 400 is the equation of the required ellipse. If the length of the major axis of an ellipse is 3 times the length of the minor axis, then find the eccentricity of the ellipse. Since a particular case is not given, let us take A greater than B case only. So for A greater than B, so length of the major axis is along x-axis and the minor axis is along y-axis. So length of the major axis is 2A is 3 times the length of the minor axis which is 2B. This is the condition given. So this here 2 gets cancelled. Therefore, A is equals to 3B. Squaring on both sides, we get A square is equals to 9B square. We have B square is equals to A square into 1 minus E square. So from this, A square is equals to 9 into e square can be replaced as a square into 1 minus e square. So a square gets cancelled. This is equals to 1 by 9 is equals to 1 minus e square. This is e square is equals to 1 minus 1 by 9. 9 ones are 9 minus 1, 8 by 9 is e square. Therefore, e is equals to 8 by 9 under root. This is 2 root 2 by 3.